Hello, this is video 7.2. In this video, we're going to be solving exponent equations and inequalities. So if we look at what our objectives are to solve exponent equations and inequalities, exactly what the title says. And our vocabulary is going to be exponential equations, compound interest, and exponential inequalities. So let's dig right into it. So if we turn to our textbook, on 7.1, we will see the key concept box. Okay, so we know what exponential equation. Basically, it's an equation where the variable occurs as an exponent. Now look at the key concept box. The property of equality for exponential functions, you have an equal sign, says let b greater than 0 and not equal to 1. That's the base. We talked about that. And if b the x is equal to b the y if and only if x equal y. For example, so what does that say? It says we have to have the same exact base. For example, if 3 to the x equals 3 to the 5, then x equal 5. If x equal 5, then 3 to the x equal 3 to the 5. So the property goes both ways. So we can go from exponential to for the exponents being equal, and then go back to exponents. So let's dig right into the examples 1 and 2. So example 1 says solve 2 to the x equal 8 to the third power. Now, in order for us to solve this, we have to have the same base. So we've got to go back to exponents. Identify the base is 2. My base is 8. These are raised to the x and the third power. They're not the same, but you should know that 8 is equal to 2 cubed. So I can rewrite this to say, I'm going to use my parentheses, 2 cubed, and it's still raised to the third power. So now what I have here is a power raised to the power rule, which says I just take and multiply the powers. So 3 times 3 is 9. So now I have 2 to the x equal 2 to the 9. Since my powers are the same, x equal 9. And there's nothing to solve for. All right, let's try the next one, which says 9 to the 2x minus 1 equal 3 to the 6x. Okay, so I have two exponents, they're not the same. However, I know 9 is 3 squared. So that's what it means. It means everything in parentheses is raised to the 2x minus 1. So using parentheses will help you to keep straight. Now, I have a power of power rule. So I have 3 to the 2 times, because I have a binomial, just like anything else, this 2 has to be distributed. So now that my bases are the same, I can go back and now I can set this equal to this according to our property. So 2 times 2x minus 1 equals 6x. I can either distribute or use the division property, which I chose to do. Minus 2x, negative 1 equal x, or x equal negative 1. And there's your solution. All right, so it's going to be on this example. So that's all it says. So that property is pretty darn important, you know. And it says, this is a property of equality for exponential functions. As long as you have the same bases, you can set the powers equal to each other, therefore solving an equation. All right, so let's move on to compound interest. We'll do this bacteria one in class. All right, you go over it and we'll discuss it in class. All right, so compound interest. So what is compound interest? Exponential functions are used in situations involving compound interest. It's interest that's paid on the principal amount of investment and any previously earned interest. So you earn interest on top of interest. So when you're investing money, you want compound interest, but not as a loan. Because then when you when you're investing, you earn more money. So the formula is A equals P times 1 plus R over N to the NT power. It's important to know with all these variables. So A is the amount in the account after T years. P is the principal amount that you've invested. R is the annual interest rate. And N is the number of compounding periods. So if it's compounded annually, N would be 1. If it's semi-annually, it would be 2. If it was quarterly, it would be 4, and so on. Monthly would be 12. Daily, 365. So that's what we use for this. So this one's slightly different than the interest formula that we used on the last section. So let's look at example 3. An investment account pays 4.2% annual interest compound monthly. If $2,500 is invested in this account, what will be the balance after 15 years? So we want to find A of T of 15 years, A of 15 years. So first of all, we start with our formula right here. A equals P times 1 plus R over N raised to the NT. So how much is invested? $2,500. So P, our principal, is $2,500. Our interest rate is 4.02, but it's compounded monthly, which there are how many months in a year? 12. So it's going to be your interest rate, 0.042 divided by 12, raised to the 12 times 15. Now all we do is put this in our calculator and we get approximately $4,600 is what we're going to have in our account after 15 years of investing only $2,500. We can put this formula in our calculator. Y equals 2,500 times 1.035 raised to the 12t, and then we can use our calculate button and value and put in 15 for x and get what y is, which you'll see it's approximately this amount. All right? So it's just really a formula and knowing exponents and how to use your calculator. The next thing is solving exponential inequalities. The property is basically the same as equalities. The only difference is we have an exponential inequality, which is just an inequality involving exponential functions. So we have an inequality sign versus an equal sign. So the property again says let b be greater than 1, then b to the x is greater than b to the y if and only if x is greater than y. If you have b to the x is less than b to the y, if and only if x is less than y. So it's saying the same thing except for you have your inequality signs and you can't flip them around. So for instance, if 2 to the x is greater than 2 to the 6, then x is greater than 6. If x is greater than 6, then 2 to the x is greater than 2 to the 6. So let's look at our 2 examples. This first one, this one example. 16 raised to the 2x minus 3 is less than 8. So we have 16 raised to the 2x minus 3 is less than 8. All right, well, I don't have the same bases, but I do know that 8 can be, I'm going to go ahead and put parentheses, that will help us so we don't mess up because we have a binomial as a power here, and our power is implied 1 here. So this can be written as 2 to the 4th raised to the 2x minus 3 less than 2 cubed raised to the first power. Now I'm going to use the power of power rules that says 2 to the 4 times 2x minus 3 is less than 2 to the third power. Now that I have the same bases, then I can write the inequality with just these. So now I can say 4 times 2x minus 3 is less than 3. And now I can solve for x. This time I'm going to distribute because 4 is not a factor of 3. Then I'm going to plus 12, so 15, 8x. And then we'll divide by 8 and divide by 8. So x is less than 15 over 8 if I did the math correctly. And I did. All right, so there's your answer. So inequalities are pretty easy. So do the example problems, and we will see you in class.